regarding free body diagrams and solving for the forces in a determinate system. So now you must know that in statics, the resultant of the forces on the object is 0, unlike dynamics that you have acceleration. So basically, you have a physical system, like here in figure on the top, you have a load, and then you have two cables holding the load. And what you need to do is first draw the free body diagram. So on the bottom, you can see that we have 3 forces. We have weight force, 736 Newton, and 2 cable forces, T sub AB and T sub AC. So in this system, you have 2 unknowns. And you have also 2 equations. It's a 2-dimensional body, and you have 2 equilibrium equations. So these equations are representing static case. So the load here is not moving, so the sum of the forces in both directions are 0. You have 2 unknowns, and by the methods that we worked in the previous session, we must be able to determine these 2 unknowns. There's an alternative method, which is law of sines. You can use it in two-dimensional cases where you have 3 forces acting at the same point. So like here, you have 3 forces acting on point A, then you can write this equation. And unlike this previous 2 sets of equations, here you can directly determine the unknowns. So if you just multiply TAB by sine of 80 and 736 by sine of 60 and put them equal together, you get TAB. But how these sine values, where these sine values are coming from? So if you have point A here, so this is point A, and this is TAB. So I'm going to draw the horizontal line like what we have in the original problem. And then I have 50 degree here. Oh, I also have a 736 Newton here. So here I have 50 degree with respect to the horizontal line, and here 30. So the relationship, the parametric relationship, is actually TAB over okay, so I'm going to write the equation here. So TAB over sine of alpha is equal to T and over sine of gamma. And what is alpha, beta, gamma here? So the alpha is the angle opposite to the force in the numerator. So this is alpha. For TAC, the opposite angle, this is beta. F 736, this is gamma. So any questions so far? So this is how we write the sine law. So alpha, so now we have to determine alpha here. So this, if this is 30, then alpha is actually 120, because the 736 is perpendicular to the horizon. It's a weight force. So this is going to be and this is so beta is 50 plus 90, 140, and gamma here is 180 minus 80, so 100. So now that you have all the values, you can easily determine TAB and TAC. Well, as you can see in the slides, it's not a recommended method. First of all, it's you can derive it from the equilibrium equation, although physically it's not really meaningful. So you'd better avoid this method and stick to the equations here that we are going to work on during the next examples. And second, is the source, is the actually possibility of errors, because in most of the problems you might not have the angles like you have here, and if you want to calculate the angles alpha, beta, gamma for these three forces, you might get to you might get some wrong numbers. So you can always use this. I mean, fundamentally there's no problem with it, but we're going to see how we usually solve these kind of problems. So for these problems, we have for two-dimensional case, we should always have two unknowns because we have only two equations. There are systems out in the world that have more unknowns, like if you add another rope here to point A, then you would have another force, and then you can't solve it with these two equations, so you need extra equations. And but in statics course, in two-dimensional case you have two unknowns, and in three-dimensional cases you have three unknowns. So let's go to the next slide. Okay, this is a any questions? Okay, so here we have two cables tied together at point C, and we have a horizontal load 660 Newton at point C, and you have the dimensions here, and you need to calculate the tension in these two cables. So you have basically, so let me, so try to solve this, and then we get back to the solution. And meanwhile, I'll figure out what the problem is with this PowerPoint. Okay, could someone tell me what's the direction of cable forces? But first, we need to draw the free body diagram. So we are going to see the forces acting on point C. And then we have two cable forces. So the directions are along the cables, the direction of the forces. And the sign is such that you would get the cable in tension. So these are the signs. So this is the free body diagram for this system. So now we have the dimensions, so we know the sine and cosine factors. So if we, right, so and then we have two equations, right? So this is the first equation that we can write is sigma Fy equal to 0, which gives this in the y direction. We only have the projections of the cable forces because the third force is along the x direction. So it's FAC sine alpha equal to FBC sine beta. And how we derive these signs, so get back here and see that So this is so sine of alpha is 3 over clear, and then beta 1.4 over so if you calculate that, you'll get this. So the first equation gives us the proportion between the two forces, two cable forces. And then we can write sigma fx, and so in the x direction we have, in the positive direction we have 660, and then the cosine factors. So we have two equations, two unknowns, and if we solve, we get these two answers. Any questions? Okay. Sorry, I didn't see your messages. C2A and C2B. Oh, okay. Yeah. The direction of forces. Thank you. All right. So let's go to the next example. So here we have a color A, which is connected to a vertical load C through a pulley. The load is 50 pounds, and the color can slide on a frictionless horizontal rod. So you need to determine the magnitude of the force P required to maintain the equilibrium of the color when X is 4.5 inches. So this is X. This is given. So think about this problem for a couple of minutes. Let me know if you have any questions. Exactly, yeah. Kevin, yeah, tension forces equal to the weight force, because if we draw the free body diagram for the weight, so this is weight C, we have vertical force equal to 50 pounds. This is the weight force, and there's a cable force, TCB. There's no other force acting on this system. So this is the free body diagram of weight C. So yeah, if you write sigma Fy equal to 0, then W is equal to TCB so one equation and one unknown. Okay. Was that clear? So here you need to determine force P. So you need another free body diagram. We have two objects here, two main objects. One is this weight that would give you the tension in the cable, and the other free body diagram is actually is representing this color with the forces acting on it. So we have one horizontal force P and one force on the top, oblique force, which is the tension force, and we also have another force. Can anybody tell me what's the other force acting on point A? So if I draw the color does not have any weight, so there's no gravity. The color is weightless. So if I write this, draw the free body diagram, I have horizontal P, then TAB. But this is not statics, because sigma Fx could be equal to 0 with this system, but sigma Fy is not, because in the y direction you have TAB, and that is a non-zero value. So you have some resistance. You have some resistance, and if you look at the physics of the problem, let me see. Yeah, normal force from the rod. Thank you. So So this color is free to slide on the rod. When it is said it's free to slide, it means that there's no friction in the rod. So the forces that this rod is acting on this color could only be in the y direction because there's no friction. So we would get a normal force from the rod. Any questions so far? Okay, so let's go to the solution. We have the dimensions. X is 4.5, and this from A to B in the y direction we have 20 inches. So we can calculate the components of this 50-pound force on the top, and then write sigma fx equal to 0. I'm sorry. Yes. So yeah. So then 50 sine alpha is equal to P, and you can easily get P. I think you didn't need to determine the normal force in this question. So writing this one equation in the x direction is enough for this problem. But if you write sigma fy equal to 0, then you would get 50 cosine alpha equal to n. And this is how you can derive n. Any questions? Good. All right, so let's go to 3 dimensions. Generally, there's nothing particular about 3 dimensions. All you have done in the 2 dimension is still valid for 3 dimensions, just one more dimension. But you need to write more algebra, and sometimes the system that you're given could be a little bit confusing because you have forces acting in the space. Finding the angles and the dimensions might be a little bit troublesome, but you shouldn't be worried about it if you really solve the exercises, the homework exercises, and extra exercises that I recommend from your statics book. You would minimize the degree of error in your answers. So the only thing you need to do for both of the parts, for both of these parts, I mean the 2 dimensions and 3 dimensions, is solving a lot of questions. It might look trivial because I'm sure all of you are familiar with physics and equilibrium, but these problems really need exercise. Otherwise, you might not get, although you get the phenomena and you understand it very well, but you might not be able to solve it accurately. So in 3 dimensions, let's just have a reminder about the vectors in 3 dimensions. So we in order to represent a vector in space, we need the direction and the magnitude. So if we have a force acting on point M, then the question is now, how do we write this vector F? How do we calculate the magnitude and the direction of this vector? So the direction comes from the geometry. You pick 2 points on the line of action, M and N, and you calculate the displacement vector. So dx, dy, dz are equal to these formulas here. And then the vector could be represented by the magnitude of the force and the unit vector. So this lambda here is a unit vector. So this d is not a unit vector necessarily, because the distance could be more than 1. So what you need to do is to normalize this vector. So you get the vector joining M and N and divided by D. So this D is actually the magnitude of vector D, vector lambda. Yes, vector D, of course. And then, so if you just simply replace this lambda into this formula, you would get fx, each components, fx, fy, and fz. And so this is just the geometry problem. So you pick points in the space and you calculate the unit vector. So here we knew what were the dimensions x2, x1, y2, y1, z2, z1 regarding points M and N. But sometimes the dimensions are not given and the angles are given. So in this case, you need to write actually fx as f cosine of theta, x, fy, f cosine theta y, and fc, f cosine theta z. So if I have Cartesian coordinates, so if this is my vector, this is x, y, z, and this is theta x, theta y, and so these thetas are the angle between the vector and the corresponding axis. So sometimes you don't have the dimensions, so you just need to write the projections using the angles you're given. So this is basically saying the same thing. Well, your R is actually the resultant force. So the resultant force has 3 components. So this Rx is the sum of the components in the x direction, Ry and Rz similar. And So any points? Any points so far? Any questions so far? Okay. So let's have a look at a problem. So we have two forces P and Q in space. The magnitudes are given 450 for P and 600 for Q. And you are given some angles. So you need to determine the resultant of these two forces. So I'll give you a couple of minutes. But the angles here are not exactly what you expect. For P, you have the angle between P and the y-axis, but you don't have the angle for X and Z. You have an alternative angle here, which is a planar angle. So you have to find a way to calculate the projections of this P on different axes. Okay, let's see how we can solve this problem. So let's start with P. P cosine of 40 would give you Py. And if you multiply P, let me write it down. So similarly, if you multiply, okay, we get to the Q later. So P sine of 40 would give you the projection of P on the XZ plane, right? So if I just draw a line parallel to XZ plane, so then I would have this rectangle here, right? So if I multiply P by sine of 40, that would give me this length, this dashed line. So this is P sine of 40. Is that clear? Okay, so everyone's clear. So this would give me this, and that is equal, because this is a rectangle, that would give me this line. Let's call this OP prime, and this is P prime. So now I have this OP prime. So if I multiply this OP prime by cosine of 25, then what do I get? Can anybody tell me? Yeah, exactly, the z component. So it would be pz. So similarly, I can write this. So if I write p sine 40 sine 25, then it would give me px. So now I have all the three components. So 450 here on the top is the magnitude of the force. So then I have sine 40, which I wrote here, and sine 25 times I, which is the unit vector in the x direction. Then cosine 40, which would be py, and sine 40 cosine 25, which is this pz formula I wrote down here. And now if I go to the q, then I can see that from the figure, q sine 55 would give me qy, and q cosine 55, which is this vector, times cosine 30, this is equal to qx, and then qz would be q cosine 55 sine 30. So here you need to be careful about the signs, as we discussed last session, because as you can see, this OQ prime, this line, has a negative z component. So when in the formula, when you're writing QZ, you must put a minus sign before this. So so I have QZ minus. So now that you have two vectors, you simply add two vectors to get the resultant force. And so based on these formulas, you can also calculate the angles between the vectors and the axis. You can later get to these slides if you have any confusions. I would upload this. So let's get to this problem. So we have a horizontal circular plate. It has a weight. So we have a vertical force. And it is suspended as shown from 3 wires. So 3 wires attached to the same point D. So you have the angles between the points on the attached points on the disk and the axis, and also you know that you have 30-degree angles with the vertical. So and you have this for the other cable. This is very similar to the previous problem, but you just need to look at the geometry and find the projections of the vectors. So if you just multiply TAD by sine of 30, you would get this OA. So, and then if you multiply this OA by sine of 50, then you would get the X component. And similarly for BD and DC. So T sine would give you the projection on the XZ plane, projections of the forces on the XZ plane. And then you multiply by another sine or cosine factor to get the projections. You just have to look at the geometry, like here. So if so, this would be TAD X, and this would be TAD Z. Cool? Any questions? All right. Let's call it a day. Good luck with your homeworks.